Hello students, let us see next example in bilinear transformation. Example, find the bilinear transformation that maps the point z1 is equal to 0, z2 is equal to minus I, z3 is equal to 2I into the points w1 is equal to 5I, w2 is equal to infinity, w3 is equal to minus I by 3 respectively. What are the invariant point of the transformation? Here we have to find bilinear transformation and invariant points. Solution, we know that the required bilinear transformation is w is equal to az plus b divided by cz plus d. For first one, z1 is equal to 0, w1 is equal to 5i, we get 5i is equal to b by d. On substituting, z1 is equal to 0 and w1 is equal to 5i, we get 5i is equal to b by d. That is, solve this one, b minus 5id is equal to 0. That is, take this d on this side, we will get 5di is equal to b. Therefore, b minus 5id is equal to 0. Name this is equation 1. Next, for next point, z2 is equal to minus I and w2 is equal to infinity. Consider 1 by w is equal to cz plus d divided by az plus b. Here w2 value is infinity. Before substituting w is equal to infinity, first consider 1 by w, because when we directly substitute w is equal to infinity, we get the whole term is infinity. That's why consider 1 by w is equal to cz plus d divided by az plus b. Therefore, 1 by w value is infinity. 1 by infinity is 0, which is equal to minus ci plus d divided by minus ai plus b. That is, minus ci plus d is equal to 0. Name this is equation 2. Then for the next point, z3 is equal to 2i, w3 is equal to minus I by 3. Substitute these 2 points in the bilinear transformation. We get minus I by 3 is equal to 2ia minus b divided by 2ic plus d. Solve this one. Take this denominator term on this side and this term on this side and solve. We get, see here, 3 into 2 is 6, 6ia minus 3 into b is minus 3b, and take these terms on this side. We get minus 2i square c plus d, and solve. We get 6ia plus 3b minus 2c plus id is equal to 0. Name this is equation 3. Let us solve 1 and 2 by writing them in the form 1 into b plus 0 into c minus 5id is equal to 0, because in equation 2 c term is absent. Therefore, 1 into b 0 into c minus 5id is equal to 0, and next equation 2 becomes 0 into b, because in equation 2 b term is absent. Therefore, 0 into b minus I into c plus 1 into d is equal to 0, and apply the cross multiplication rule. You know that what is the cross multiplication rule. On applying cross multiplication rule, b by 5 is equal to minus c by 1 is equal to d by minus I, because 0 into 1 is 0, minus I into minus 5i, minus into minus it is plus 5i square. I square value is minus 1, therefore it is b by 5. Here on solving, we get mod of minus 5. Mod of minus 5 it is plus 5, therefore b by 5, which is equal to, next term is minus c divided by 1 into 1 is 1, minus this is 0, therefore it is 1, and similarly d divided by 1 into minus I is minus I into 0. Therefore, b is equal to 5, c is equal to minus 1, d is equal to minus I. Substituting these values in 3, we have 6ia plus 15 plus 2 plus 1 is equal to 0, or simplify this one, 6ia is equal to Add these terms, minus 18. Therefore a value is minus 3 divided by I, or which is equal to 3i. Minus 1 by I is I, therefore it is 3i. Thus the required bilinear transformation is W is equal to 3iz plus 5 divided by minus z minus I, or multiply I both numerator and denominator, we get minus 3z plus 5i divided by minus iz plus 1. Then consider b is equal to 5id from equation 1, and c is equal to d by I, which is equal to minus id from 1 and 2 respectively. Using these in equation 3, we get, means substitute b is equal to 5id, c is equal to minus id in equation 3, means in this equation we will get a is equal to minus 3d. Choosing d is equal to 1, we have b is equal to 5i, c is equal to minus I, and a is equal to minus 1. Thus the required bilinear transformation is W is equal to minus 3z plus 5i divided by minus iz plus 1. Here we have to find bilinear transformation and invariant points. This is the bilinear transformation. To find invariant points, consider, let us take W is equal to Z for finding the invariant points, that is Z is equal to 3iz plus 5 divided by minus Z minus I, or solve this one, we get minus Z into Z is minus Z square, minus I into Z is minus I into Z. Take this term on this side, we get minus 3iz minus 5 is equal to 0. Solve this one, minus z square minus iz minus 3iz is minus 4iz minus 5, and take negative sign on that side, we get, or multiply negative sign on both the side, we get z square plus 4iz plus 5 is equal to 0. To find invariant point, solve this one and find the values of z. Consider z is equal to minus 4i plus or minus square root of 4i square minus 4 into 1 into 5 divided by 2, which is of the form minus b plus or minus square root of b square minus 4ac divided by 2, which is equal to minus 4i plus or minus 36 square root of 36i square divided by 2. Therefore z 4i plus or minus 6i divided by 2. Solve this one, we get z is equal to I, or z is equal to minus 5i. Thus the invariant points are z is equal to I comma minus I, minus 5i.